Hello, my name's Ethan Kim. My pronouns are he, him, and the two courses I'd most likely tutor for is CS64 and CS32. I'm excited to become a tutor because I know how potentially tedious and hard some of these CS courses can be when students choose to disregard the material or choose to memorize the material rather than really understanding the content. And I'm excited to be in a role where I can kind of bridge this gap such that students choose to understand the material in that the courses become a rewarding test of understanding rather than a test of rote memorization. And for my explanation, I decided to explain the MIPS calling convention from CS64. Before getting into what the calling conventions actually are, I want to demonstrate why you need calling conventions by going over a simple C++ code. So if we look at the C++ code, we have int x equals 10, int y equals foo 54, and we see out x plus y. And in the foo function, we call bar, and then we return a plus b. And in the bar function, we see out 6. So this is a very simple piece of code that we should immediately understand what it does. But I want to ask some questions that the compiler usually asks for us and answers for us that in MIPS, we have to be the one asking and we have to be the one answering. So when we call foo 54, where do we put 5 and 4 such that the function foo can find it? Or when we have the function, when we call the function foo, how do we know for certain that foo won't be modifying x? Because we need x and y later. Or when we run foo, how do we ensure that once foo finishes running, it goes to this line in specific? And when foo does run, where should we return a plus b such that the main function can find it? And these questions can also be asked for the bar function. And these are questions that we have to now answer in MIPS. And the calling conventions is a really streamlined mainstream way to do so. So going back to answering some of these questions, where do we store the arguments we have to pass, such as 5, 4? We would store them in A0 or A1 or A2 or A3. Where would we store A plus B? We would store them in either V0 or V1, generally just whichever one comes first. And then what if we have values that the function shouldn't modify, like a and b in this case, or x here, because we need them later? We would put them in the S register, and we would put like where we should return to in the return address register. And we put them there because the S and RA register should not be modified by the function we're about to call. The obvious question at this point is, what if we have to call another function, such as in this case, foo calls bar? We can't use the SNRA register again, can we? Because maybe the main function is potentially using the SNRA register, so we shouldn't be changing it. So at this point, we kind of have an ingenious solution, which is simply pushing the values of the SNRA register into the stack. And this may sound a bit confusing right now, but in the example I'm about to go through, it's going to become a lot more obvious. So we have this MIPS code, which is actually the same code we have here, except in MIPS. And I'm going to go through the portions that are relevant to the calling conventions. So, like we said, we need to store x in a location that isn't modified by foo, or shouldn't be modified by foo. So we put them in S0. And we have the two inputs, 5 and 4, and we store them in A0 and A1 because the calling conventions say we should put them there when we have arguments we have to pass. And we simply jump in like foo, which updates the return address and goes to foo. At this point, we have to understand that foo is going to call bar, the function, and we know that bar may potentially modify A0, A1, and it's going to modify the return address. So we need to put values into those registers, but we know that those registers may already be filled since we're in a function. So at this point, what we do is add unsigned it at stack pointer -12. This says we're going to use 12 of the bytes in the stack pointer. At this point, we use the save word function simply to upload S0, S1, and return address into the stack. At this point, we could safely move A0 and A1 into the stack before calling bar, which simply just prints out 6 and returns back here. And because we know bar didn't modify S0 and S1, we store the sum of S0 and S1 in V0 because that's where we put return values based on the calling convention. And after doing so, because nominally from the main function's perspective, foo shouldn't change these registers, we have to retrieve the values of S0, S1, and return address from the stack by using the load word function. And we once again use add unsigned int because we're no longer using those 12 bytes in the stack, and we return. Going back to the main function, we know that the v0 is where we store return value, so we move that to t0 before adding that with s0 into a0 and printing that out and ending the function. And this is my explanation of the MIPS calling convention.